explain the various activation functions used in a neural network. Let's see. The simplest activation function is the linear activation function. The linear activation function transforms the input linearly to produce the output. It has the form g of z equals z and takes the values in the range minus infinity to infinity. Another popular activation function is the sigmoid activation function. The sigmoid activation function has the form g of z equals 1 by 1 plus e power minus z and takes values in between 0 and 1. The sigmoid is not a linear function. It's a non-linear activation function. Another popular activation function is the tanh activation function. The tanh activation function is defined as g of z equals e power z minus e power minus z by e power z plus e power minus z. The tanh function takes values between minus 1 and 1. It is similar to the sigmoid function, however, it takes values between minus 1 and 1 and is sort of a scaled version of sigmoid, is one way to think about it intuitively. Both the sigmoid and the tanh activation function suffer from the vanishing gradient problem. Sigmoid more than tanh. The next activation function is the ReLU activation function. The ReLU activation function has the form g of z equals max 0 z. So if the value of z is negative, it will give an output of 0. If the value of z is positive, it behaves like a linear activation function and just gives the value of z. So the range of values that the ReLU can take is 0 to infinity. It cannot take negative values, which might pose some problems. So to fix that, another activation function that's popularly used is the Leaky ReLU activation function, which is defined as g of z equals some small constant a into z if z less than 0 and it is equal to z if z greater than or equal to 0. And this takes values in the range minus infinity to infinity. While the ReLU and the Leaky ReLU do not have the vanishing gradient problem, one challenge with these two activation functions is that the activation value itself might blow up when we use these two functions. So these are the various activation functions that are typically used in a deep neural network.